Everyone, thank you so much for coming, and also congratulations to everyone who participated. Can you guys give yourselves a hand? All right, so as Mike said, these are our 6 amazing final judges who will be judging the top 8 presentations. I want to quickly introduce Kim Polese, chairwoman of Clear Street, also on Obama's Advisory Innovation Board. We have Professor Bob Doherty, who directs the Neurobiological Imaging Center at Stanford. Professor Mendel Rosenblum, also co-founder of VMware. We have Mar Hershenson, co-founder of Pejman Mar Ventures here in Palo Alto. We have Ellen Levy, who is the managing director of Silicon Valley Connect, and John Lilly, who's the previous CEO of Mozilla and current Greylock partner. So, wow. These are probably some of the most amazing people you can have in the tech industry. So we want to quickly, if you guys can introduce yourselves, where you're from, kind of critical moments in your career and where you are now, and highlight of your week. Starting with Kim.
Okay. And how long do we have for these little?
About a minute each.
About a minute, okay. Got it.
About half an hour.
Yeah, I know, we could go on all day. I'm Kim Polese. I grew up in Berkeley grad, sorry. Biophysics. Yay, okay, good. Biophysics, computer science, and got my first job in the Valley at an AI company. I very quickly learned the difference between great technology and a market that's actually ready for it, and the surrounding infrastructure, that needs to be there in order to take a technology into the market. I learned that lesson again at Sun, where I was founding product manager for Java. Very interesting ups and downs to get Java out to the world again. Learned that lesson, and then was CEO of a company called Marimba. Founded that with 3 of my colleagues from the Java team. It was one of the first internet infrastructure companies, systems management, cloud computing, you'd call it now. And basically, I've been a CEO, founder of multiple startups. I love helping founders, and particularly with that challenge of taking great technology and finding a market fit, and all that goes into that. So delighted to be here today.
Great. So I'm Bob Doherty. As you heard, I'm the research director at the Imaging Center here. It's actually in the basement of the psychology building right across the way here. And I grew up on the East Coast. I actually studied psychology as an undergrad and in grad school. And I got into brain imaging. And from there, I got into MR physics. And now I'm doing a lot of everything, all these different things. One of the things that really drives me is the curiosity about how the brain works, but I also love technology, which is why I think my job is perfect for me. I get to play with a lot of cool technology and also interact with a lot of great research on the brain, how it's working.
Yeah, I'm Mendel Rosenblum. I've actually been a professor here since 1992 in computer science department. I came from Berkeley, where I got my degree. And so, my work, here has mainly been in operating systems and low-level software. In 1998, myself, a couple of my graduate students, and my wife founded VMware to transfer some of the ideas we were working on virtualization out into the industry. More recently, a couple of years ago, my wife had another company. I joined them, and I learned how to build web applications and wrote many lines of JavaScript. did things like worked with designers on how, doing good user interfaces and stuff. So I'm very excited to see what we have today.
Hi, my name is Mar Hershenson. As mentioned, I'm co-founder of Pejman Mar Ventures, and I know a lot of you guys. We work with a lot of the students trying to turn their projects into companies if they want to, or at least into something that users would use. My background, I'm from Spain, from Barcelona, Spain. I came here in '95 to get my PhD in electrical engineering, and I've started several companies as well, from zero all the way through acquisition. So I'm familiar with all the ups and downs that happen within minutes of each other. So very excited to be here today.
I'm Ellen Levy. I now run my own company called Silicon Valley Connect, doing a lot of angel investing and advisory work. So I have about 50 companies that I'm currently involved with. But jumping to the punchline and then a little history, I quickly figured out that I like sampling a whole ecosystem around entrepreneurship and innovation, both from the different disciplines and also from the industries that they impact. So I was pre-med for 2 years, mechanical engineering for a year, and became a psych major as an undergrad at Michigan. Anybody from Michigan? Nothing. And then I ended up coming out here to Stanford and got my master's and PhD in cognitive psychology. So similar comments around not only being intrigued by the brain, but being intrigued by how we could use some of the language that was coming up around computer science to try to talk about how the brain worked. And we could take some of the inspiration of how the brain worked and start looking at how technology could work. And so when I left grad school, jumped randomly, I met a guy on the golf course at Stanford who turned out to be the #2 guy at Apple. And when I went to Apple, I was his chief of staff effectively. And what I figured out was my passion was sitting right at the intersection between people and technology. And so I've done venture capital for about 6 years. I spent nearly a decade involved with LinkedIn from the beginning and have ultimately ran corp dev and strategy. And like I said, now I just like working with lots of entrepreneurs, figuring out how what they have to offer comes into the world.
Cool. And I'm John Lilly from Greylock. I guess I'm the most Stanford homer here because I got here in 1989 as an undergrad in WE and CS. My master's was in computer science, was in human-computer interaction at the very early days when Terry Winograd was putting that lab together. One of the things that I did when I was here is I did a thing called section leading, which I helped teach CS 106, which is probably the single best decision I made in my whole career to date. It set up a lot of the relationships and the things that I do now. So fast forward, I went to a company called Trilogy for a while. I was at Apple when Steve Jobs came back, which was entertaining. And then it was entertaining. And then I started my own company called Reactivity, and then I ended up going to Mozilla in the middle of 2005. So I got to Mozilla when it was about 12 people. We grew it to be about 350 people and about 450 million users globally by the time I left. And then I joined Greylock. And at Greylock, I've been investing in things like Dropbox and Tumblr and Instagram. And my favorite thing that happened last week, related back to section leading, was I had a board meeting for a company called Quip that I'm involved with. And Quip was started by a guy named Brett Taylor, who was a section leader. And I got to know him through that lineage, through that history. So anyway, this is unbelievable, by the way, to come back and see 300 people in Stanford, 600 people all together. This is an amazing thing to witness. So congratulations.
All right, so just to mix it up a bit, we'll have 2 questions. You have a choice of which one to answer. One is, what do you want to see in the future in terms of technology? What are you hoping to see? What do you think is coming? And the other is, has there been a pivot point in your career where you had to make a really big decision and how that played out? So this time we will start with Professor Rosenblum. If you are ready.
You know, I think, well, you know, a really big pivot it was, I just love building software. It's like the thing that makes me happy, and I try to do it. And I had a decision of whether I wanted to be a professor, since I also love teaching and doing research and stuff. And so in 1992, I made the decision to, you know, come here to Stanford, and I enjoyed it. Then I went to VMware and had the time of my life for the first, you know, Stanford lets you take 2 years of leave. For 2 years, I had more fun than I've ever had before, and then I had to make the toughest decision of my life, since it was clear it was going to be incredibly fun to be at VMware, but I came back here to Stanford and had, you know, another 10 years of fun.
Yeah, go for it.
So yeah, I've been thinking a lot about healthcare and how technology can really help the healthcare industry and just help people be healthier. And I think all the new apps coming up for health monitoring are interesting, but I think we need to do more. I think we need more serious applications. Some of the things that are kicking around are using big data techniques to, in my field, to look at neuroimaging, and neuroimaging data is already quite big. Even you get data on one subject, you've got millions of points of information, even from one person. But then taking that and scaling it up to thousands of people, and that's a very rich data set, and I think there's a lot of information there. But as my background's in behavioral psychology, I think there's a lot more we can learn from behavior and how technology can really help that. One thing that I've been thinking about a lot is how we interact with our smartphone devices. And as a psychologist, I see all those interactions as little experiments, little trials of you have a stimulus coming in and you have a motor response going out, and it's probably telling us something interesting about how our brain is working at that moment in time. And so I think there's a lot of potential in this area.
So actually, it's an interesting question because there was a pivot, both a pivot point and it's related to your question about my hope and for technology and dream for how it can be applied in the future. And that is, I spent kind of the first chunk of my career really focused on pure technology and infrastructure and software, Java and all of that. And I love making technology better. but I decided I wanted to really focus more and more on how to technology and focus it on solving big, huge, seemingly intractable problems. One of the ones I've particularly zeroed in on is financial services and the problem of the fact that innovation really is not coming from the big incumbents. It's really, as always, it comes from the ground up, and there's so many challenges that we have with 76% of the population living paycheck to paycheck. So can we create solutions, for example, to attack that issue, or job skills gap issue, or climate change and so forth. So I'm working with a bunch of companies right now that are focused on different components of basically trying to apply technology to solve really big, hairy problems.
Well, maybe I had almost the opposite decision making than him, so that's interesting. I always wanted to get a PhD because I thought I was going to be a professor. I went through an interview process, which is torturous, and I signed an offer letter. And at the last minute, I decided, it was 1999, and it was crazy in 99 here. Everybody was starting companies. Even if you didn't have an idea, you would start a company. So
Definitely not like now. Not like now.
Not like that.
it's true. So people, I literally, people would come to me, oh, you have to start a company based on your research work. I'm like, I'm not even, at that time there was an internet, but there was no content on it. So there were no blogs about starting a company. I remember going to the Stanford bookstore and buying a book on how to start a company, and it was published by IEEE. So that will give you a hint of how, how informative it was. But anyway, so at the time I said, okay, fine, I'll start a company. I'll let this professor job go. And once my first company was sold, I said, well, now I'll be a professor. And again, I said, I made the decision not to do it. But today I work with a lot of the students, so I feel like I'm getting to do a lot of that. Anyways, I don't regret it, but I still miss school.
So mine is more, what I'm excited about is this is going to be a little high level. I'll try to give an example or two. I'm really intrigued that technology has evolved so quickly and so many people can harness it that we don't have to think about the technology anymore. It doesn't mean that you don't have to be good at it, but we have to start thinking about the use cases way more. And so I'm intrigued by anything that says you can truly put the person, the user, the customer first. And it's a pretty profound shift. It's not just a transition. I think it's a 180 from where we've been. Two examples. You mentioned healthcare. It's going to come pretty quickly where we're going to look and say it's ridiculous we all take the same medicine at the same time, or that we get the same treatment when we could know a lot more about how to do it per person. Education's another example. If you think about a fixed variable and a dependent variable, we've always said the fixed variable is how many hours you sit in that seat, and the dependent variable is how much you learn. And now, because we're able to deliver so many different ways to different people through different mediums, we can now say the fixed variable is how much you learn, and the dependent variable is who you learn it from, how much it costs you, all kinds of things. And so I look across almost every field, and I think that I get really excited about how technology is now so vast that it's more about cutting through and making it so it feels like every time I'm doing something, I'm doing it for each individual person.
That's a good answer. So like two pivot points. I've known Ellen for a long time, but every time she opens her mouth, I learn something new. Anyway, so two pivot points for me, and one was in the building that used to be here, which was called the physics tank, which was like this building but uglier and duller. And when I came to Stanford, I was going to be a physics major, and I took freshman physics, and I was very, very bad at it. And I struggled, and I struggled, and I worked, and I got a C+ in my first freshman physics class. Like, maybe I should not do that for a living. And so that caused me to go to computers, which is I kind of understood. And then I was lucky to take classes from guys like Mendel and like President Hennessy. But then I was working at another company that Kim mentioned briefly called Sun, which probably none of you have ever heard of, because then they got bought by this company called Oracle, which was a very weird thing, and now they're kind of disappeared. But when I was at Sun, there were two refugees from Apple who were there, a guy named Bob Glass and a guy named Bruce Pagnazzini. And I was so interested in what Professor Hennessy was doing, which is how do you make architectures that go fast, make very, very fast microprocessor architectures. And Bob Glass said to me, who cares how fast it is if nobody wants to use it? And he said that to me in 1993 or 1994, and that led me down a journey to go find Terry Winograd and David Kelly and think about design and human scale computing. And that seems like a very consistent answer among this group, which is we're all looking for how does technology and humanity intersect in a way that's really intimate and powerful.
All right, so our final question is, thinking back to college, if you have any advice for these college students here who want to, I guess, change the world, looking back, what advice you would give to your 19 or 20-year-old self? Just like quickly, 20 seconds would be great.
One thing I'll mention is that I think, I love this Yo-Yo Ma quote, which is all the interesting stuff happens at the intersections and the edges. So the intersections of disciplines and the edges of where you're pushing, each discipline at the boundaries. And so that's actually one of the reasons I majored in biophysics. I just love this idea of applying digital sciences to biological phenomena. And so the more that you can find, then that led me to computer science, and kind of the melding of all of that ultimately is one of the things I'm working on now too. And so I would just encourage everybody to think about how to intersect with other disciplines to solve really interesting problems.
I think I probably don't actually need to say this to you, but something that I feel strongly about myself is if you enjoy making things, make stuff, right? So that's something that's always been a passion of mine, from hardware and software, and even as I think I was in middle school and computers were first coming out. I had one of the first. It was a Sinclair, I think it was called. I just started programming, and you couldn't do much with those. But I think that if you have a passion for that, it's really important to just keep doing it and keep exploring.
One of the things I noticed in watching VMware become a big company is, and it's true almost every big company, is you don't see a lot of innovation coming out. And the innovation that did come out, I would study it and then almost always track it down to an individual person. And even though there are tens of thousands of people in the company, this one person got something going and got other people around them and made something happen. And it's true if you look at all the successful open source projects. There's usually a person with a vision and drives it, and that my encouraging, be that person that makes things happen, be a doer.
Well, I'm glad I'm fourth because, they said some of my answers. I can time, but different. It's getting very tough. I have one advice that I wish I had done when I was a student, which was, I think, one of the most important skills we should learn is people skills, and how to get along with people, how to manage people, or just people skills. So I don't think there is. My kids joke with me that I'm going to teach people skills one day, but I do think it's really important. I don't know if you learned that in the psychology department, or if you go out there and practice your people skills in tough situations. But I think that's the most important when you go out there in the real world.
Yeah. All right. I think I'd probably throw out. I think I was pretty good at it as an undergrad, but I stressed about it a lot. So I would say, don't worry about it. Is the notion that when I was in school, there's a lot of pressure for, are you getting the grades? What will you do next? It's like a means to an end. And now I look at it and I go, oh my gosh, you're sitting in such an amazingly rich environment. Just sponge it up because it's cool. Like, it's fun. You can learn stuff. If you don't enjoy the class, figure out why and how would you teach it differently. Like, make everything look like it's in the moment. Because when you leave, I guarantee you look back and you go, I'd go sit in that class. Like, I look over at the classes going on at Stanford, I'm like, I'll go sit there for a year. Like, that's awesome. So I just think of it sponging it up. It's all stuff that will come back along the way. And it's not just nail the grade, check the box, and you've got another step to your degree.
Yeah, but I think my advice would just be a little more prosaic than all of this, which I think is all excellent advice, which is mostly don't be in too big a rush. You're all amazing for doing this, but when I look back at my time, a lot of the connections that persisted over the last 25 years, not 27 years now, it keeps going up, are just like going to a baseball game with buddies and going out to hang out with people. a lot of stuff does come from like the dedicated time and the hackathon and like actual coursework. But this is a very special place with very special people at a very special time. And don't be in too big a rush to get out and be Snapchat or whatever.
Thank you
But
so
if you do, come talk to him.
Yeah, if you do.
Just to be clear.
I like your information.
Thank you so much. Can we get another round of applause for our panelists? So we're going to transition into the top 8 presentations, and we'll have the judges come to the first.
We just hand you the mic? Sure, great, awesome. So I'm gonna need one. Ready? Hey everybody. So first up on deck in our we're now going to move into top 8 demos, and we're just gonna get started. First up on deck, we're gonna have Pantry.
Hi guys, I'm Caitlin and this is Erin, and this weekend we worked on Pantry.
So if you look at this, you might not instantly think kitchen appliance, but this idea is supposed to go in with all of the smart home appliances and specifically smart kitchen appliances that we're seeing coming out. So I did sort of a literature review of the existing smart fridges, and a lot of them pretty much do inventory management, and they focus a lot on grocery shopping, which is like a thing that you do if you have a fridge, but I mostly think about opening the fridge to get food to eat it. So this is what that's for. It helps you make healthier decisions when you're opening a fridge to eat the food from it.
So we start off by logging you in through Fitbit. So Erin and I are both big users of Fitbit and MyFitnessPal, which includes a feature where you log the food that you eat throughout the day. And so we go ahead and take that from you, and we use that information to basically figure out where you are in the food group sort of scale. So based on like what you've consumed in what portions, we kind of figure out like how many like vegetables you've had for the day, how many like fruits you've had for the day, and which things you should eat more of and which things you should stop eating like for the day. So what you see on the screen right now is actually just like a digital representation of what you see physically in the fridge or pantry or whatever you'd like it to be. We only had 3 pieces of, I have this bulb every time. Here, you keep going.
All right, so we have representing here our shelves where you would pre-sort your food into different categories. So the same idea as I think most people, you get vegetables, you put them in the vegetable crisper drawer, you get pasta and rice, you put them on the same shelf. So this would be expanding that idea a little bit more, so you would just exclusively keep vegetables on a vegetable shelf, exclusively keep grains on a grain shelf kind of idea. And then these are the lights telling you whether or not you should eat things from that shelf.
Yeah, so the lights, it's like a stoplight system, right? So red for stop, green for go. They actually interpolate between red and green based on what they are. So this is based on like whatever daily intake we've had put in today, but just to see a different one, we'll switch to, if I can click on it. So this is a totally different like nutrition system. I have to refresh the page for you to see it, so I did it on my phone. But basically now you have like 0 vegetables for the day, so it's green for the vegetable shelf, et cetera. And so that kind of thing, if you have it set up for like all 5 of your food groups, it's really helpful. And so we also took this a little bit further, and we decided that sometimes when you open the fridge, you're not just there to like grab a single thing and put it in your mouth. You want to make something. And so we basically integrated Alexa to take it to the next step. And this is our first time demoing with an Alexa or an Echo because we haven't had one the whole time. So we'll see how it goes. Alexa, open the pantry.
Hi there. What can I do for you?
What should I have for dinner today?
It looks like you didn't eat quite enough vegetables today. What about cheddar broccoli casserole tonight?
That sounds good.
Glad to hear it. Enjoy your meal.
Thanks. Okay. So there's a couple other things we did. Turn off. Thanks. Are we done? Okay. There's a couple other smaller features, but that's the overall thing. So yay. Okay.
Do you have time to explain tech stack or no?
We're actually going to give the judges like 1 minute to ask like 2 questions.
What was the hardest thing about building the system?
I think getting all the hardware components to talk to each other. We're definitely more software engineers than hardware engineers, and so dealing with different networking protocols, and so we're actually like, running individual servers on each of the things displaying screens here, and then those need to communicate with a cloud-hosted server, and so dealing with like local networks versus cloud hosting, that was the most challenging thing for me at least.
We actually had a couple real like halfway through the hackathon, we like did not have any sort of like working light system, which was kind of like one of like the flashier / bigger selling points. So we that was probably really challenging for us too. Yeah.
How would you get this into the market? What's your go-to-market plan?
Yeah, so actually the thing about this is that it's super easy to implement in like literally any space. So we use LifeX bulbs here, which are like really expensive and totally overkill, but they were like like I said, we had many light struggles. But like what we originally planned on doing were these like LED strips that are really cheap, and eventually you could basically mass produce these like smaller like light setups so that you could like just line your pantry with. All you have to do is sort your food by food group, and then as long as you're using Fitbit or MyFitnessPal to log like your nutrition data, it's all easily to communicate.
That's the difference between this and like the major mass market things by like Samsung you see right now at CES, where like, they're selling you a $10,000 refrigerator when like people own their refrigerators for 10 years, and that's like a really huge investment. And what if a cooler thing comes out next year? Whereas like this could be like a definitely sub $50 system.
I have a quick question. As a user temporarily, I guess, of the MyFitnessPal, it's kind of a pain to enter any of that data. Are you still entering the data? How much of the data saving, entering, would you save with this? Or
So we don't actually save any of that friction, unfortunately, which is, I totally agree, that is like the most painful part of MyFitnessPal. But it's the best way to get the most accurate information at this time.
do you think you can estimate it, maybe like weight, like weighing?
Yeah, I think there are totally existing smart fridges that do that now, that have like scales and fancy
Okay.
things.
Awesome. Thank you, Pantry. All right. Next up on deck, we're going to have the Connect Awakens.
Hello? Hello? This is on? This is on? Hello? 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 All right, all right. I know. I appreciate it. Can you guys move? Can you guys move? Like out of the way, please?
Maybe the props.
There are 3 prizes: most technically complex, most creative, and most polished. And most technically complex. And we're going to focus on technical questions for the hackathon. Thank you. Sorry, I didn't brief you guys.
So that was a really great hack, all about using really, really cool things about nutrition. One of the best parts about hackathons is that we get to see all these great things that really can impact your lives. I really, really want to use that. I know when I came over to see them during the expo, I saw the lights flashing up, and I was like, oh, my goodness, I'm having more of these vegetables. And that kind of accurately describes how I felt, that noise. So this team, it sounds like, may be a Sith Lord. We're going to find out soon about that. But it sure looks exciting. Some of the cool things that you can see that they're setting up right now, and I'm sure they're going to tell you about in more depth, are a Google Cardboard, which is a really, really cool device by Google that turns any Android phone into a really rockin' 3D imaging device. Additionally, they're using a Microsoft Kinect, which can actually track your full body. It's got 2 infrared cameras in it, and it creates a skeleton for you. So you can do some really impressive things that we're going to start seeing really shortly here. They're also using a really great technology called Unity, which we're going to hear about again in more depth here. Unity is a 3D gaming engine. It's absolutely incredible, and in fact, they are a sponsor of the Major League Hacking Hardware Lab, which means that we get to see incredible, incredible professional hacks using that Unity at hackathons all across the world every single year. Every time they make that noise, I get really scared. Does that happen to everybody else too? Like a little bit of joy, like, oh my gosh, Star Wars. Yeah. Wait, actually, who saw this new Star Wars? All right, does everybody know the spoilers? Luke is Vader's son. Wait, you didn't know that?
How much longer do you actually need? Go. They're good.
We're good to go? Awesome. Can I give you the mic? All right, let's give them a big round of applause.
Hello? Hello? Hi, I'm James from University of Toronto, first year of computer engineering.
Hi, I'm Angie, third year at Georgia Tech.
We have one more teammate. She had to catch her flight, but she's, I believe, fourth year EE major at Maryland. Maryland.
Shout out to Kate.
All right, cool. So, as of you guys know today, we have the Oculus Rift, we have the Vive VR coming out. These are really cool devices. They're introducing VR and AR to everyone. But as you guys know, Oculus Rift costs $600, and Vive is potentially more so. And I don't think anyone has $600 to spend on some gaming device. At least I don't. Maybe you guys do. So yeah. So given that, we developed a system to have a lot lower cost to do the same thing, more or less. So what we have here is the Kinect. We have the full skeletal tracking motion stuff with the Kinect, and then we have a PS Move controller from PlayStation. This can track orientation. It also lights up, so you can track the light bulb. So what we have with the Kinect is
Okay. So the Kinect is sending. The main things that the Kinect are sending back to us are the location of James's head and the location of the location of his head, and then also the location of his hands. So we're using the location of his head to actually place the camera in our virtual reality world, in our Unity game that we built. And then we're using, obviously, the hands, and then the IMU in the device looks exactly like this for the lightsaber, to know where it's actually going, where it's located in actual 3D. So in our game, we have like a villain that you're fighting. And so not only can we see where you are like in a 2D plane, but 3D. So you can dodge him by stepping backwards, go up to hit him, things like that. But, okay. Well, technical difficulty. Okay, but sound effects. Yeah. Okay, yeah.
So the cardboard thing isn't working right now, so we're gonna try to show what we can.
So
wait.
Cardboard's really hard to show on your laptop, but hopefully some of you guys got to come around to our booth and actually see it. But
why is this moving? Oh, it's my head?
yeah, it's your head. Okay, well, you can kind of see up there what the world would look like if you were looking at it in cardboard. That's the guy you're trying to hit. So.
Sorry. Technical difficulty, sorry.
Yeah.
Awesome. So next up on deck, we have Adu. And just,
Judges, do you have any questions?
Oh, wait. We're trying to get it moving. But yeah, if you have a question or two, feel free to ask.
Maybe you can talk about how you implemented the positional tracking with the PS4 and why you did it, why you did it that way.
I can do that. So with the position tracking, right now since we're doing a virtual environment, we don't need the exact data from. It's so close. Okay, yeah, so we don't need the positional data exactly. So you can see there, sort of like that. So it's moving. So the PS4 is tracking my right hand, actually. The Kinect is tracking my right hand. That's where it displays the lightsaber. And then it's tracking my head to keep track of where my head is. We can get the orientation data from the phone itself. We can get the orientation data of this thing from itself. The hard part was connecting it all together, because this runs on Unity. I mean, this runs on Ubuntu. Kinect runs on Windows, and then we have this thing running on its phone. So getting all that connected together and networking, that was the hard part.
Thank you to Connect Awakens. All right, we're going to bring Adu on deck.
That was an absolutely incredible hack about virtual reality, right? One of the things I like the least about virtual reality is, like, back when it was just like a game, I could actually play it and be all right at it. But now with virtual reality, like, I have to be physically apt, and it feels too much like real reality. Also, I'm last picked in them, so I don't know why that happens, but it's one player. You all ready? Awesome. Give him a round of applause.
Hey everybody, my name is Will, and I'm up here with my brother John and our friend Peter, and we are excited about programming. Is anybody out here excited about programming? Yeah, that's right. We want to share our excitement with as many people as possible, and what that means for us is sharing it with young students and getting them excited from the very first lines that they write. And Peter's going to tell us how.
So here we have our product. So in the upper left-hand corner, you can see that we are allowing users to create a scene using XML, predefined XML nodes like a tank, if you can see. I can't really see, but and then you can also create a scene including blocks like we have up there, and then defining functions that allow users to move the tank and control it, and the console to execute those functions and other functions on the tank. So John's going to demo shooting a tank, or shooting a block from the tank. So first he's going to target the tank, my tank, and then the turret .aim, and he's going to select a block on the screen, and then he's going to, it gives us the object of the block and inserts it into the console, and then he can aim at it, so the tank is now aiming at the block, and then now he can shoot, fire at the block. So yeah, that is the core of the demo here. We have also, we implemented the on the JavaScript function on the left here because we wanted to, in case the user wanted to, doesn't want to write the same function over and over again, they can just create a function and then, for example, go in a circle a bunch of times. So yeah.
Yeah, so we got this idea because a couple of months ago I visited a low-income school in Brooklyn, and I saw a friend was teaching them to program. He was teaching them Python, and the goal was to build an asteroids-like game. So the motivation was you get to blast asteroids, but the problem was it would take about 200 lines of code before you can actually start blasting the asteroids, and that's pretty difficult to get people excited about the programming when you have to write 200 lines of code. So basically, the objective here is to maybe in 1 or 2 lines of code, get them to do something that they want to do when they look at the scene. And also, we think that it's important to have a more object-oriented approach to learning to program instead of some of the more traditional, like Scratch, that use control flow as their main sort of lesson. So yeah.
All right, so some future steps that we're looking to take is we're going to make some levels. We'd love to make some levels with objectives and start them off on the terminal, make them make some functions, and then eventually get them building their own scenes and making their own levels. That's where we want to go.
Awesome. Thank you, Edu. Judges, do you have a question? That's fine.
I just have a quick question. Did you guys start this project during the hack, or you've been working before?
Yes, we started this during the hack.
Very cool.
Awesome.
Thank you.
Next up on deck, we're going to have Slip.
Testing. Can we start whenever? It's midterm season. I'm 5 lectures behind and I need to catch up as soon as possible. Some professors have been merciful enough to post their lecture videos and slides, but who has time to watch videos on 1.5 speed anyways? So I'll go straight for the slides. And Guy's gonna show us, me, very desperate student, just flipping through. So let's say I'm going through a typical CS 103 lecture. I don't really understand set theory as I'm reading about direct proofs. So I don't understand set theory. I wanna go to that place in the lecture so I can get a better explanation, so I can hear Keith explaining it. So I click that button, and it takes me to exactly a second before where that slide actually appears in the video. So we would like to tell you about our algorithm today. If Guy want to put back the flowchart. Hi, I'm Janelle, and I'm in charge of telling you about our pre-processing pipeline. So all the user has to, our process is entirely automated, so all our user has to give us is a slide deck and a video. And so what we do is we use the FFmpeg libraries to take the video and extract keyframes. So instead of taking like 25 frames per second, which will give us like hundreds of thousands of frames, we use keyframes. Basically, if a certain sequence of frames have been static or not unchanging, then we only take the ones that are different from all the previous ones, so we only get a few of them. We also use image magic to change our PDFs or PPTX into PNGs, so that we can compare the images together.
So as far as like comparing a frame from the video to one of the slides from the PowerPoint, what we used for our feature detection algorithm is an OpenCV implementation of SIFT. And the advantage of this algorithm is when you compare two things, instead of doing a pixel by pixel comparison, you're looking at edges, corners, and special cases. So if something is scaled differently, angled differently, it doesn't matter if it's like a corner, like some dark corner of the video, it would still pick up the match.
So it turns out with just feature detection, we could get to about 70% accuracy. And we looked through what was failing, and we found that a lot of the times when it failed, there was a lot of text on the screen. So we figured, okay, perfect, let's add an OCR. So then what we did is we found all the characters in the slides, in the frames, and we matched them up together. So we used an algorithm to see how similar they were. And in order to get high accuracy, what we ended up doing is we looked through all the slides and all the frames, and we make a grid of how close the slides and the frames are. And then you can match them up in order. So as you move to the next frame, or the next slide, the next frame has to be somewhere ahead of the current frame you're on. So you can imagine like moving through the grid, trying to choose the best frames as you go through each slide. And using this, we're able to get about 90% accuracy for going to a specific frame based on a slide.
And a brief overview of the stack. So our backend is in Python and frontend is in JavaScript. We use jQuery. Server side was was Flask. And then, so basically you upload the files onto the server, and then it returns a JSON object of all the timestamps for where each slide corresponds to where it is in the video. And then the front end will map that out.
So you've fallen behind in your classwork, you can slip ahead with Slip.
Thank you, Slip. Do the judges have a question?
Yeah, just one short question. So, if I understood you right, one of the techniques you used to improve the accuracy was to look at the order in which things are done in time. What if the lecturer goes back a slide or two and then goes forward? Can you account for that?
Yeah, so we thought about that a little bit. So generally, if he goes, let's say from slide 2 to slide 3, the algorithm will, and then back to slide 2, the algorithm will pick up the first slide 2 and the first slide 3, and he won't account for like the second slide 2. And this kind of makes sense when you're thinking about like watching a lecture, because you want to go to the first occurrence the slide had to make sure you're not missing anything. So it automatically adjusts for that because it wants to get in slide 3, and that's the only way it can fit it in.
And because we use FFmpeg libraries, we can also record the timestamp, so we know exactly when the slides start, and we can record that segment so that even if you move back, we still have the timestamp, so we know where you are in terms of the slides.
Awesome. Thank you, Slip. Next up on deck, we have Arthur.
Hey guys, wait, do we get a mic or?
Yeah.
Hey guys, this is Arthur, your in-home virtual assistant. Arthur is a program that runs basically on an iBeacon, which acts as your home. As soon as you go into your home, it sends you your daily report, and Arthur provides a nice intuitive experience of attaching all your favorite APIs and all your favorite come home utilities into one app. As you can see, these are all the native apps, the native APIs that are available right now for iOS, like health kits, reminders, and events. But realistically, you can append anything that you want, like Uber API. Let's start by going into what Arthur does. Arthur, what's up? Oh, is there no sound? Sure. Oh, that's the microphone. Ooh, that's cool. Don't sound. Okay, you can try. Okay, so what Arthur did right there is he went over the whole list that we just had right there. We can go in again. No, it's okay. All right.
All right, so this is, you might be wondering why it's like the theme is like night. We have a morning feature in development. So essentially imagine Arthur waking up in the morning and telling you, oh, good morning, Adrian. Today you have these planned, and by the way, last night you missed these and these and these. So essentially we're trying to make a seamless experience through Arthur. So thank you.
Thank you, Arthur. Do the judges have a question? That's fine. That's good. Awesome. So next up on deck, we're going to have the Queen's speech.
Awesome. Can we give them another round of applause? So I don't know about all y'all. I think you might be a little bit the same generation, but did y'all have a lot of thoughts about the friendly aardvark during that? No? Okay. Just in case you need to know how to spell aardvark, that's A-A-R-D-V-A-R-K. And if you've watched the first episode of Arthur, that makes a lot of sense.
Thanks. Hey guys, so we're all a little nervous coming up here presenting in front of you, and we kind of wish there was an app that would help with that, so we decided to make that. So we're Queen's Speech, and we built a 3D virtual reality application that helps you practice public speaking. So the user enters the virtual world and sees a moving audience, and then we give them stats on how their speech was after a certain amount of time. So what we calculate is we calculate clarity and eloquence of speech, we calculate how they span the audience, and we calculate their pace. And Ingrid is going to give you a little demo.
So first you start recording, and Queen's Speech will record your audio, and meanwhile it tracks your eye contact with the audience, counting how many times you engage with different parts of the audience, and then when your recording is done, you can play it back. Meanwhile, it tracks your eye contact with the audience, counting how many times you. That's enough. And we tried to use Microsoft's project Oxford to do speech to text to count how many times you use the word like or and then these numbers you see in the audience. God, this is so hard. This is why we need this app. Represent. I'm done. How many times you engage with that section of the audience, making sure that you are spreading out your eye contact. So Joan here is going to talk about the technical.
So the way that we created this application is we used Unity, the game engine, and as you can see here, we have a spherical 360-degree view. And one of the challenges that we ran into was that you can't have movie textures for an Android or iOS mobile application on Unity. So what we did to tackle that challenge was actually to split up into multiple different frames this 360-degree Bernie Sanders rally to to be able to to be able to create a more realistic experience for the user, because we thought that more than a static picture, having a video of real life audience would be more exciting and more realistic for the user.
And so we got a lot of great feedback from the like opening demo we had, and some things we want to do in the future probably include saving user data, I think, is one really good thing. And another thing is I like to think about this potentially as like Google Maps for speech. And so throughout your speech, you could potentially have guidance about your pace and whatnot. And so thank you.
Thank you for that. Do we have any questions from the judges? All right.
Thanks, everyone.
So next up on deck, we have hands-on math.
So Mike, for the record, you had one there. All right, here they are.
Hi, everyone. My name is Farhan, and this is Ashna, and we're hands-on math.
Okay, so before we give our spiel, how many of you are at some point of your life like intimidated by math? Raise your hand. Okay, most of you. So we figured that the most of why people are scared of math is because it's abstract, a lot of numbers, we don't get it. So we thought we'd make it easier, more fun, more visual, more interactive by making hands-on math. So what our app does is lets you draw curves or lines in thin air, and we take that data and give you information about what that curve is, what mathematical equation is in that curve, and Farhan's going to give you a small demo and talk about how that's done.
Yeah, so the app uses the leap motion, which is a kind of cool interface that lets you draw stuff with your hands. You can draw little points like this with your finger. When you're done, when you're done, you can stick your fingers out like this. It knows not to track you, and then you can wipe everything off the screen. So we can draw like a quadratic function, kind of like this. It's not the best, but it's the best I can get right now. So, and then we're gonna go and send it for some analysis, and it'll tell us what it thinks I drew. Oh, well, I guess it wasn't that good. Let's try again. Let's try again. That's not that good either. And as you can tell, I didn't learn that much math. Yeah, there you go. So it looks something like that. So the things we were kind of interested in doing next would be like having full data, manipulation with your hands, being able to turn it and stretch the data with your hands and transform waves and such like that would be really cool, and to see how the parameters change as you do that was something we were really interested in. We just think it'd be a really cool way for kids and anybody who's interested to learn about math and really feel like they have it with them rather than that it's something that's away from them. So yeah.
Just a sneak peek into like what we did in the full stack. So basically we use obviously the leap motion, and we used 3JS for graphics, and we fed the curve data into Wolfram Alpha and had it basically render the best fit for us, which we outputted. Yeah, that's all. Thank you.
Thank you, Hands on Math. Are there any questions from the judges?
Like, how much information did you get from the leap, and how much did you have to figure things out from raw data or something?
That's a good question. The leap is actually pretty good. It fills in most of the curve for us, but some things, like when you start, kind of the points are a little off because it's kind of trying to detect you, and when you end, sometimes there's like a little trailing. So so we kind of cut off the starts and the ends of the curves. You have to do a little bit of manipulation, but you don't have to do that much. And I think it was really cool in that it did most of the work for us. It was great. So yeah.
Awesome. Thank you, Hands on Math. Finally, we have a recon on deck.
Ranging everywhere from finding, I don't know, say humans in a stranded location and helping democratize that process, or just finding your beach balls on the beach. So here what we have is a live feed of the drone. This is going over Lake Log at Stanford, and what is happening is it takes images every so often, and it classifies those images. Do those images have a beach ball or not? So as you can see here, this image over here does not have any beach balls, and what the classification is going to return no beach ball if you just see the last line of it. So what's interesting about this is actually a consumer drone, the drone that we're flying right now, and we wanted to make the accessibility of search drone available to everyone, so we used a consumer drone. But the drawback of that is you can't actually program that drone, so you can't take images with that drone. So what we did is instead we live streamed the drone to I know how to use a microphone! Anyways, I know how to use a microphone. I promise. So what we're doing is, what we do is we live stream the footage. Okay. So what we do is we live stream the image from the drone to our Android phone, and what we do is we have a script on our computer that continuously takes snapshots of the Android phone and loads those images onto our computer. So this is a little hack to be able to take snapshots onto our computer for classification. So as you've seen a little of the classification, but you might now be wondering, it classifies pretty well, but that's just beach balls. How can you do other objects? Like, you're not going to be on the beach all the time. So to do other objects, we thought, hey, what if you could do other objects with your voice? What if you could do computer vision with your voice? So what that would entail is something like, hey, Alexa, imagine a beach ball. So what would happen... What would happen is it would imagine a beach ball. What would it do? Through a series of communications, it would get to our server, to our ultimate, to our laptop. We would query the Bing API, and we get a lot of images of beach balls, and we build a classifier on the spot. All you have to do as the consumer is say, imagine a beach ball, and it does all of the computer vision for you by fetching all of the data and running the machine learning algorithms. So then our third part is, okay, so let's say you found a stranded human, for example, but now you want to actually get things to him. Maybe you want to get medicine or some supplies he wants. So you need to be able to do that. What you're going to have to do is use some sort of delivery drone. So what we put together, a really small hack for you guys right now, despite various internet issues and whatnot, but we have a small hack to show you how this delivery drone works, which is a little different from our search drone. All right, are you ready, Marcus? Hey, Alexa. Start recon.
Welcome to recon. Let the recon know you want it to launch by saying recon launch.
Recon launch.
Recon is about to launch. Give directions.
You can hear it right outside. Impress me.
Here goes nothing.
Land.
Goodbye.
All right, okay, it has an attitude. But, and those are the main parts of our project, being able to create a search drone that can classify any object.
Thank you, Recon. Judges, I think we have time for a quick question or two, and then we're going to ask you to go outside to deliberate. Perfect. All right. Thank you to all of our top 8. So at this time, I'd like to invite the 3 people who founded the first TreeHacks last year to do sponsor prizes. Oh, we're doing thank yous first? That's awkward. Vincent is going to do our thank yous before we do that. We're announcing sponsor prizes afterwards. What kind of thing? Music. What music do you want? Wait, the audio doesn't work, remember? No, I can't. Audio doesn't work.
Hey, everybody. So thank you all for sitting with us for the first part of our closing ceremonies. I just wanted to go ahead and say thank you all for coming. This has been an incredible event, and we could not have done this without you. We, the 30 organizers on the team, the tons of people who we've reached out to over the last year have all done this for you, and I'm so grateful that you're all here with us. So please, a round of applause for yourselves, and thank you all for coming. To start, I want to thank our mentors. We had a great mentorship system built by Rafi, and this was really the core of our support system and supportive environment at TreeHacks. So a big shout out to our mentors. I want to thank Professor Mendel Rosenblum, John Lilly, Professor Bob Daugherty, Ellen Levy, Mara Hershenson, Kim Palesi, all of our final judges who are in the other room right now for taking the time of their busy, busy lives to spend their weekends with us. I want to thank Dr. Marta Zanchi, Ryan Panchadsaram, Dr. Henry Way, Joel Worrell, Dr. Peter Karth, Dr. Oliver Alami, and Dr. Robert Cheng. And you probably guessed this was for the health initiative. And I want to thank them for giving us mentorship throughout the weekend and holding a great panel on Friday. I want to thank Hee-Jae Lim and Ahmad Wani and Jared Kastner for helping us with the Social Good Initiative. She++, Wix, and OSTEM for providing us with community support for our huge diversity pushes. Because we were the first 50-50 large university hackathon. Shoshana Copland for lending her son, Rafi, her car for the weekend. Steve and Laura Wadsworth for lending their daughter, Christina, their house for the last few weeks, where we literally put tons and tons of goods and things that we shipped. So thank you guys so much for that.
He's talking in metric tons, by the way, not just like tons of stuff.
Yes. I want to thank Marty Von Racefield from the Stanford University Fire Marshal's Office. Mark Bryant from Elevators and Escalators. You guys might be able to think about a little bit of what he did this weekend. Fabian Pease, Jerry Kane, Tom Kosnick, Tim Chow, who gave a wonderful keynote speech on Friday, for their support within the Stanford Computer Science Department. Amy Rogg for the yoga session. John Asenso for the Zumba session. Kate Park for her guided meditation speech. DJ Khaled for Major Key. And overall, all these activities were a great way to get you guys hyped up throughout the weekend. I want to thank Brooke Groves Anderson and Jeff Gordon from the University Corporate Relations Office for helping us put together such a great event and get in contact with some of the greatest companies in the Valley and around the world. Brian Kaneda from Parking and Transportation, the Sisters of Kappa Alpha Theta for lending us their home for storage again. Brian Kaneda for Parking and Transportation, Tim Gormley and Chris Bells from Stanford Recreation, Ralph Briones and Robert Katayama from Stanford Center of Professional Development, all the catering companies who provided you guys with the great food so that you guys could have something nice in between your work sessions. Photographers, Tony Chung, who's out in front here, and the photographers from MLH, who are doing a wonderful job this weekend capturing one of the weekends that hopefully you'll never forget. Kenny G and Vicky Crillo from Electrical Engineering, who helped us with our scheduling. Frank George, the building manager of the Huang Engineering Center, which is where you guys worked all weekend. The Society of Black Scientists and Engineers for lending us their space this weekend. The residents of the Huang Engineering Building, who very graciously lent us their space over the weekend. to perform our activities, and they're the people and the grad students who actually own the space and share it with us. So the ICME department, including Margaret Gerritsen and Mary McDevitt. So thank you very much to these people. I want to thank Tim Adenolfi from security for giving us comfort throughout the event. Victor Cuevas and Linda Fung from custodial services. Steve Clark for putting together the great hardware components lab upstairs that you might have seen in the Forbes Family Cafe. Pam Davis and everyone from the Stanford Daily for helping us create a new sense of journalism that we'll hopefully be able to share in a few minutes. Shai Ruparel and Nick Quinlan, who have been running around all weekend and providing us with great support all month from Major League Hacking, and we couldn't have done this without them. Chris Lau, Carlos Sejas, Brian Wenkel from University IT, and they are the reason that your Wi-Fi did not go down and that you were able to build things. So that is a really amazing feat. Darren Evans and the whole team at Event Services for setting this entire place up. Huang is not usually an event space, but we made it work with Darren and his team. So that was huge, and you guys got to see one of the most beautiful parts of our campus. Lindsay Aiken and Veronica Chavez from the Stanford School of Engineering Scheduling Department, who really helped me make this happen throughout the last 9 months, just talking to them and booking this space and getting us in contact with the right people. And finally, from Student Activities and Leadership, O'Neill Patrick, Snehal Naik, Sarah Salem, and Nancy Howe, who's sitting right here. Thank you so much, Nancy, and your entire team for your support throughout the last few years. We definitely could not have done this without you. And we really do believe that you are pushing forward something really much bigger than ourselves in tech. And finally, I want to thank the organizers who have worked so hard over the last school year. I'm so glad to call them my family, and they have brought so much enthusiasm, and they are the people that we will still hang out with and call in 30 years. So I'm so glad to have met them. And finally, a big round of applause to you guys again. Thank you for listening to me give all these thank yous, and more fun to come. So a big round of applause again. Thank you so much.
And of course, we all want to thank Vincent and the other two co-directors, Christina and Rafi. Let's hear it for them. They put this all together. They spent a year doing this, and they couldn't have done a better job. All right. And of course,
the marching band.
The University Marching Band. All right. Now we have a quick video to show everyone. Probably.
That's not good. No, it's not. It's not on mute. It only looks like it's on mute. Okay, we're gonna do this. We're gonna do this. We're gonna do this.
So while the computer people figure out how computers work, what was everybody's favorite part of TreeHacks? Just shout it out. Yes, the food was great. Absolutely. What was your favorite meal?
Option click on the value.
Soylent was. Love Soylent. They gave us great things. Soylent was not your favorite meal. Hummus was great though.
That's not gonna
Sounds like a video.
Yeah, it's not going to play on the thing.
Really?
The HDMI pin must be broken because when you switch it, it just doesn't work.
Of course, I'm sure it's the HDMI pin, Mike. I'm confident that it's the HDMI pin. That sounds like the thing that it is. It's digital, man. It's not. It's fine. Yeah. Okay. We're gonna do sponsor prizes. We'll come back to this once we figure out how to plug in cords.
All right. So before we go down this long list of sponsor prizes, I want to say one more thank you to all the sponsors who made this event happen.
Okay, we'd like to invite down Illumio to give away their sponsor prize.
Hey guys, my name is Asaf and I'm here with Illumio. I just want to say that we are super excited to be giving the first prize for today. First of all, a big round of applause to all of you guys for doing such an amazing job. We were so impressed. So please, thank you. Before we give our prize, I want to just say a little bit about who we are. A lot of you guys asked us, and no, we do not make traffic cones, even though we kind of looked like it all weekend. We are a cybersecurity startup, and we are kind of changing the way that security is done in the cloud by making it really adaptive and smart and all that kind of stuff. We're working on really cool algorithms, and obviously we're looking for people to help us implement those algorithms. And so if you're interested in us, please reach out for internships or full-time or whatnot. So for our prize, we judge on the best use of data visualization. And that's because a lot of what we do involves visualization as well. That took a few shots. And so the team that we were the most impressed by, again, there were so many incredible hacks, but we decided to give our prize to Echo Chef. So please give them a round of applause. And they built this really cool thing that helps you in your kitchen, and it helps you cook, and it shows the visualization that they did was that they showed you how a lot of your ingredients were related to each other, and we thought that was really, really awesome. And then lastly, a lot of you guys know that we were raffling the Avigant Glyph at our booth, which is a really, really cool device. It's coming out in like 2 months, and over 200 of you signed up for that. And the winner is Daniel Wilson from Princeton. Are you here? All right, you won it. We can't give it to you right now because it's not out for like another 2 months, but we will mail it to you, so we'll reach out to you. All right, guys, thank you very much.
Thanks so much, Asaf, and thank you, Illumio. We have a long list of prizes. I'm going to read them off one at a time and tell you what they won, which company provided it, and the team name. So first off, we have Best Use of SendGrid's API. These winners get a winner's choice prize, anything they want up to $500, and it goes to MailTrail. Woo! The next prize is Best Use of Amazon Alexa, which we saw a lot of today. And these people will win Amazon Echoes for the entire team. This goes to AirScribe. Woo! The next prize is Best Use of Best use of AV equipment goes to our team. And the best use of Intel hardware, this team will win drones for the team, goes to Sizer. Best use of the Uber API, 75 Uber credits for the entire team, goes to Memento. The best use of Watson and Bluemix from IBM, this team will win Parrot drones for everyone, goes to Recon. The best use of the Facebook API, everyone will win Oculus DK2 developer kits, goes to Appception. The best use of data visualization, which is sponsored by Qualtrics, and they're going to win Soma Explorer quadcopters, goes to Here VR. Best use of Wolfram technology. This team will win Raspberry Pis, Visa gift cards, Wolfram Alpha Pro for 1 year, and a Wolfram development platform account for a year. This goes to Hands On Math. The prize from 1517, 1K grant for the team to keep working on their project, goes to Ether on a Stick, The Queen's Speech, and Recon. The best use of the Dropbox API. Every team member will receive 100 extra gigabytes of Dropbox space. Goes to Amalia. The most cupcakey prize, also sponsored by Dropbox, and they will win a sushi making set. Goes to Love.js. The Aiming Higher prize, also sponsored by Dropbox, will win a choice of Samsung VR headsets or Bohm wireless headphones for the team. Goes to UCLA Rideshare. The best travel hack, sponsored by Airbnb, and the winners will get Airbnb credit, goes to Wander. We have about 7 more. Best use of Microsoft technology. These people will win a Microsoft Band V2, Microsoft iOS kit for Raspberry Pi 2, and it also goes to Here VR. And this prize is for the team that was most thoughtful with security in mind, and it's sponsored by NetSuite. This team will win GoPro Hero 4s, Fitbit Flexes, Phil's Coffee gift cards, Dylan's Candy gift cards, Williams and Sonoma gift cards, and NetSuite gear. Those are all NetSuite customers, by the way. This team is Impatient Decision.
Also, sorry, we have 3 more prizes from Amazon because they're that cool that they wanted to give out a lot of prizes. So Alexa prizes also go to Recon, Pantry, and Alexa MD.
We have a prize from Flipboard, and the prize is Tour of Flipboard and Lunch with the Flipboard CEO. And this goes to iVision Test. Best use of Amazon Web Services from Amazon goes to Recon. And TreeHacks has a social good prize in partnership with CS Plus Social Good for the best hack that makes a social impact, and that goes to Amalia. We also have a prize from Major League Hacking. This goes to the Best First-Time Hacker Award, and the winner of this prize will get Dell Venue 8 tablets. It goes to Slip. Lastly, we have a prize for the funniest use of domain.com. This team will win a bunch of swag. It goes to Get Cured. All right, and that's our list of prizes. One more hand for everyone who won prizes.
All right. All right, now, as you guys know, this weekend we also had a TreeHacks Health Initiative. This was entirely spearheaded by Sherman, who is amazing and incredibly passionate about this. He's going to talk about it for a minute.
Hey guys. Is this on? Okay. I just wanted to say a huge thank you to everybody who participated on a health hack this weekend. We had an incredible turnout. 33 out of the 84 projects submitted was health related in some capacity. And I just want to give a huge round of applause to everybody who did that. Our organization Shift and TreeHacks, along with TreeHacks Health, have been working like side by side with doctors, clinicians, nurses, everybody in the healthcare space to make these projects possible. And we were so impressed by the people who actually took up the needs that we proposed on the website and actually started working on some of the projects that they submitted. And I just wanted to encourage you guys to keep on working on those ideas, especially because the innovation game in healthcare is a long-term one. And so it's not going to be solved over a weekend. And we do hope that you continue to develop those relationships and carry these hacks forward. All right, that being said, without further ado, I do want to name the winners of our TreeHacks Health prizes. The best mobile health app that is winning Muse headsets goes to Gate. For the best wearables hack, sponsored by Misfit Wearables, they're getting Misfit Shines. It goes to Alexa MD. For the Mental Health Innovations Prize, sponsored by Stanford Center for Youth Mental Health, Stanford Center for Youth Mental Health and Wellbeing, it goes to Momento. And finally, for the best big data hack, sponsored by Oscar Health, they're getting 23 kits. It goes to Clo.
Thanks so much, Sherman. One more round of applause for TreeHacks Health.
So if you just won a sponsor prize, some of the sponsors are going to want to meet you after the closing ceremony. Outside the first floor hallway in Hewlett, we've set up, there's like signs with every prize. If you go to your sign and wait like 5 minutes, hopefully your sponsor will meet you there. If not, they just probably like, we'll get in touch with you later and we'll make sure the connection happens. Some of them have already left. Awesome. Now you can go. Hey. When it's time to kill time, what's up? When it's time to kill time, thank Pam for making this. I did it. I did Progress is leaving. What? I screamed this, and then we should play this, and I was never playing it. I was like, oh.
50 different universities, 8 different countries. So I think you all ought to be pretty proud of yourselves.
We can each open one. Do you want to open the Guinness Award one?
Can I do Polish?
Huh?
I really want to do Polish.
Why?
Oh, so did we already announce beginners?
Huh?
We already announced beginners. MLH's? Slip?
Oh. So do you have like nice lighting? To be obnoxious.
Really fun, really different seeing these doctors walking around and being able to talk to them.
Our goal here is to break down those barriers so that we can have different perspectives, different mindsets, so that people are solving different problems and they come up with different solutions to those problems.
You know, the quality of a student is not measured by what they know, but by the questions they ask.
Yeah.
Yeah. How many hours till deadline then?
That's 11 hours and 15 minutes.
I feel like it's just really great working with my teammates. Really awesome experience.
We got nothing last night.
Yeah.
We'll be the winner. We're not sure.
I hope that for the next 36 hours, you build some stuff, you meet some new people, you learn to ask a few great questions, and when you go home, and I know a lot of people talk about this, but how you might actually be able to change the world.
Really quickly, we want to thank Pam Davis for her hard work, not just on that video, but maybe you saw some of that incredible artwork for a few frames. Pam's been working really hard all weekend, painting your faces to make a really interesting art project out of your facial expressions. And she's going to have more with that in our Facebook group in the coming weeks. But one more shout out for Pam. Now I'd like to introduce the TreeHacks co-directors, Christina, Vincent, and Rafi.
No, we need to put that one. Take Russell.
Hi, everyone. Thank you guys so much for coming out this weekend. We're so happy to have each and every one of you, and we thank you so much for your hard work. It's definitely been rewarding to see you all have a great time at TreeHacks, and yeah, thank you. Give it up for yourselves. We would now like to announce the TreeHacks top 3, but we're doing it a little bit different this year. We have most creative, most technically challenged, and most polished. Sorry, most technically challenging. It has been a long weekend for me. I'm going to start with most creative.
It's gonna be.
Give it up for pantry.
So, give it up for pantry one more time. Explain the prize a little bit as you give it. Do you want to explain it? I don't know. What is it?
And so we chose you guys for most creative because we wanted to choose something that, you know, we chose these prizes to help embody the spirit of TreeHacks, which is technically challenging, being very creative and loving what you're doing, which is what we thought you guys really showed us in your hack. And so we thank you guys for doing that this weekend and for coming out to TreeHacks. We're excited to give you most creative.
So I'm going to announce the most technically challenging prize winner.
And the winner goes to...
No statuettes, sorry.
Recon. So we were really impressed with Recon because, as they said earlier, they did use consumer drones. So these are the things that you buy at the store, and they're not for developers. So they really did go into the hardware. I know they personally spoke with me to, you know, grab a bunch of different parts and everything, and we could tell that they really put in a lot of effort to embody what it means to hack something together in the most literal sense. So congratulations to Recon.
Give it up one more time. Congrats. Cool. So our last prize is most polished. This was this was to the team who made just, you know, the fit and finish, made it look really good, kind of tightened up all the little edge cases, just kind of shipped something that didn't even look like a hackathon project, looked like, you know, something that you'd actually want to use. So, I mean, okay. Okay. Didn't mean it like that.
And the award.
Everything else after a little bit of more, you know, polish. Let me check this out. And the winner goes to the Queen's Speech. Congrats.
Thank you.
Great. So, Christina, we'll talk about our prizes.
So to announce our actual prizes, for most technically challenging, we will be doing a flight to a city of your choice. For most polished, we are doing dinner at a Michelin star restaurant. And for most creative, we are doing concert tickets. Awesome.
Do I have to go to the dinner?
We're done. Thank you guys so much for coming out this weekend. And just as a reminder, if you won something, there are posters up around the outside of this auditorium on the main level. Go find the poster to get your prize.
What's up? What? Buses?
So, okay, wait, we're about to tell you the logistics for how to get home, so hang tight for 1 sec, or you might not be able to get home. Before we do that, we have one more sponsor prize to announce, which is the Intuit's Choice Prize. This team wins Chrome backpacks, and it goes to Slip. Woo! And now I'm going to hand it off to Mike to tell you about logistics.
All right. So there's like a few groups of people. If you took a bus here, you're taking a bus back. It's at 4:30 Lawson Mall, and we will have groups leaving from from Huang, actually. We're going to be leaving from Huang in groups to buses if you want help getting there. In addition, if you are flying out of SFO, we have one bus going from SFO. So those people should also go with the bus people and get on the SFO bus. Do not get on the SoCal bus because you will be very sad. If you're going to another airport and you got an email from me, you have an Uber code to get to the airport. That's it, I think.
Actually, one last thing. Okay, who had a fun weekend? I know it's coming to the end. Okay, you know why you had a fun weekend? Well, first of all, because you're awesome people, and this is a hackathon, so why wouldn't you? But really, it's because a bunch of organizers spent their weekends, their days, their nights, their GPAs working on this for you. Can you give them a big round of applause? And anybody in a white shirt, come on down.